Welcome to Square One, the podcast where we explore the beginnings of tech journeys and dive deep into the latest tech topics with industry professionals. I'm your host, Sarath Sridhar, and in each episode, we blend personal stories with insights into the ever evolving world of technology. Let's dive in. Today, we are going to talk about accelerating Industry 4.0 and 5.0 with digital twins. We are joined by our guest, Mr. Arunkumar Palanisamy. Mr. Arun, we are glad to have you here. Could you please tell our listeners about yourself and what exactly you do in tech?
Wonderful. Thank you, Sarath, for hosting me.
Uh,
It's really a wonderful session. Let me quickly introduce myself. I'm bringing more than 2 decades of experience in digital transformation, product development, and accelerated development to our ISVs. I am the CEO at Kasadara Technology Solutions. We are fine global ISV providers and partners. We focus more on product development solution providers. That's the quick brief about myself. Is Sarath.
Okay. Can you give a one-liner of what Kasadara does?
We are a product development company, and we started coining or offering product development as service kind of product outsourced company is what at this present that we focus on. So we are blend of customer focused product development and our own in-house product development company. If I talk about online about Kasara Technology Solutions.
That makes sense. To give a context, met Mr. Arunkumar during the start of my career, and we were building a prototype for IoT devices. And technically, he's the first industry professional I met. And
Oh,
so in college, I met him and gave a presentation about how we are going to implement the prototype and how we are going to move forward. And I was really surprised. When I was going to the meeting, I was really nervous because this is the first time I'm explaining it. And um, the encouragement that he gave was really wonderful, and still I remember the encouragement that he gave. Like it's been like 10, 12 years, I think. I still remember that. So I used to say I did not have access to internet those days, and I did not have high speed internet. We could not afford that. I just finished college, so I saved everything that I researched in HTML pages. I saved the web page and accessed it, whenever I needed access the data. It costs money, right? So Arun was really amazed by that, and he encouraged me, and so that since I'm not a bright student in college, and when you get into the industry and when people encourage you, it takes you a long way. So still after 10 years, I remember that because this was like a wonderful moment I had. So yeah, thank you,
wonderful.
Mr. Arun, for
Still, you're yeah,
yeah,
good,
I
good,
still remember
Sarath.
that.
Oh,
Yeah.
still you're remembering. There is a bell which is ringing in my mind that our meet up at one of the hospitals somewhere that we met each other. Good that it's 15 16 years old story that you have brought in. Still, I was thinking it's about just a few years back we met each other. It's good that
It's been
recollect our
like
old
10.
memories.
Yeah, it's been 10,
Good.
10, 12 years, I think.
Yeah, could be good. Good that you're remembering still. Go ahead.
Thank
Yeah,
you. And thank you for encouraging me. And it was easy to talk to you and easy to learn from you. Uh,
hey,
so
you were brighter one. I like your humbleness.
thank you.
Anyhow,
So let me jump into the digital twins topic back. So digital twins. I just want to know, can you please explain what digital twin is for a new listener? what digital twin is and how it has been a game changer for Industry 4.0. I would also be happy if you could explain what is Industry 4.0 since we are trying to uh, convey the message even for the beginners.
Yeah, it's a really fantastic and wonderful topic that we discuss about amidst of digital transformation and the AI wave. So essentially, if you talk about digital twin, it's a dynamic virtual representation of an asset or a processes system. If I talk about onliner, think of it as a highly detailed living digital mirror that reflects the real world counterpart. This is not
Uh,
just merely a 3D model
mhm,
wherein you will see the graphical representation of sensors, different machine manufacturing machines, or trading machines, or fleets as such. Rather,
mhm,
it's uh, or incorporates real-time data,
mhm,
historical information, and predictive analytics to
mhm.
simulate and understand the behavior of its physical twin. You can
Okay,
imagine that you have a factory where it manufactures, let's say, car.
okay,
Obviously, it has to go through different levels of assembly lines and you know phases. Imagine that the manufacturing area or manufacturing unit has got about more than 20 individual units,
okay,
wherein the supervisor or the person whom in charge of the factory to monitor every segment of what's happening inside the premise or the factory. It's impossible for that person to go and monitor each and every
okay.
units and its different phases. Rather, that's where digital twin do the magic, where it portrays or real time you can see what's happening inside the factory. That is the typical use case or a classical example I can talk about. There are
Okay,
different
I think I get
characteristics.
it.
Yeah.
So this is basically you clone all the activities of the factory and all the operations, and you know uh, transfer everything into a digital system so that you can monitor the factory, how the process is going on. Even you can simulate the data, or even you can get the real time data, and it gives the usually the supervisor of the factory to understand the real time functioning of the factory and how the products go from one sector to another sector. Did I get that right?
In a way, yes, very high level, it is true, but it has got lots of nuances and different applications that it could yield out of digital twin. Let me explain a couple of applications that we could yield out of digital twin, right?
Sure.
Mm. One is important thing why digital twin. Obviously, essentially, as we discussed, it is meant to monitor and do the optimization across manufacturing or production line, and also make sure operational efficiency is being the evident. That's why we normally go with or the industry is demanding to have digital twin. As said, application. If I talk about digital twin, it's monitoring and diagnostics. What does it mean? Let's say digital twins continuously ingest data from different sensors. As said, each manufacturing unit has or will have their own machineries. If you typically go with the legacy model, the machines are machines. It doesn't have any intelligence. It's all about being operated by the operators. Where digital twin add value is that mixing up with sensors, IoT, AI, and things like that. We'll discuss in detail. As said,
Mhm.
the sensors are being mounted in the machines, and the it is being connected or mounted with the systems. This allows for real-time monitoring and performance of the machines and identifying the anomalies, diagnose the potential issues being occurred in the machine level before that lead to costly downtime. Imagine
Okay.
being able to see a machine
Mhm.
components starting to overheat in a digital realm, right? And addressing it proactively in the physical world. Could be of an example. of monitoring and diagnostics of the digital twin. Other aspect,
Okay.
if you see, yeah, predictive
So
maintenance.
can I re-enroll it in a similar way? So, for example, you're monitoring all the, let's say the factory has lists of conveyor, set of conveyor belts and all other multiple units operating, and if a particular part of the factory is malfunctioning, or let's say a machine is overheating, even before you meaning to say that even before the problem, if we use IoT and AI, we'd be able to detect the problem. Is that
Ab-
correct?
Absolutely. So that is the other application. Monitoring,
Mhm.
obviously, the monitoring and diagnosis and its historical information or historic data of the machine could lead towards predictive maintenance rather than reactive maintenance. The biggest
Okay.
challenge the industry going through is the reactive maintenance. Why? When it happens, obviously, once the machine is down, then
Mhm.
only the maintenance team get the alarm saying that, hey, this particular machine has been down. It's not affordable for a assembly line to get, one of the machine get faulty. If it
Okay.
get a fault, obviously that is the kind of a ripple effect to the other sequence of activities. That's where digital twin yields the biggest benefit is predictive and maintenance. How it happens?
Okay.
It is
Mhm.
about analyzing historic data and real-time performance. Here, digital twins can predict when equipment is likely to fail, as said, right? This shifts
Okay.
maintenance strategies from reactive to proactive. You understand the reactive and proactive here, right? So,
Yeah.
which optimize the resource allocation and minimizing the disruptions is what the biggest application of digital twin.
Okay. So
Hmm?
in simpler terms, I'm just trying to put it in pieces. If a machine runs at, let's say, 100 degrees Celsius for continuously 4 hours, it's more likely to fail, because we could, from the historical data, we could see that. So this, if the machine runs in so and so temperature, I'm just giving a simple unit. There may be multiple parameters involved,
Correct,
so I'm just trying to
correct,
understand
correct.
with the
Yeah,
smaller parameters. So if it's like history repeating itself. So if it goes in so and so way, so and so problem is going to happen. This machine may fail, or
correct,
this machine may need maintenance, and it
right,
will alert the supervisor to go and check that. Did I get that right?
right. Simpler term, you're right. But
Mhm.
again, the thresholds are based on the parameters and the conditions of the manufacturing unit or machine. Say an example, if you take cement manufacturing, right?
Okay.
The rock and clay should be heated at 3000 degrees Celsius.
Mhm.
It has got its own threshold, right? It should not cross beyond 3000 degrees centigrade. If it crosses, obviously, that will give the ripple effect across different places or different parts of the unit or the production unit. So, in a nutshell, I can say each machine and the parameter machines will have its own parameter. Each parameter could be, as I said, heat, pressure, and water inflow.
Okay.
Kind of a typical parameters will have its own threshold and upper
Mhm.
limit. If it crosses, obviously that is where the challenge starts and lead towards the machine's fault or downtime, right?
Okay. Got it.
Yeah. Digital twin, not these two applications alone will ended up. Other benefits, if you see, improved operational efficiency. How it does, how it is being done. As said, it provides a holistic view of operations, allowing business to identify bottlenecks, optimize workflows, and improve overall efficiency by having monitoring and predictive flows in place. For instance, in a manufacturing plant, a digital twin of the enterprise production line can help optimize material flow, reduce waste, and increase throughput. Right?
Okay. Yeah, got it. Obviously, like if we monitor a real-time system and we could predict that, I could understand that even the if we could maintain it will help us continuous production without any failure, and
Right.
even we can monitor the real-time situations. This is a really
Correct.
interesting tool.
Correct.
put it into my focus.
Correct. In an
So in
essence,
the
if we talk
Mhm,
about digital twin,
mhm.
it bridges the gap between physical and digital world,
Okay,
providing invaluable insight that empower industry to make smarter, faster, and more efficient decisions. They are a
okay,
cornerstone of Industry 4.0, which
okay,
drives a paradigm shift towards more intelligent, connected, and resilient, industrial operations. If I
okay.
talk in a nutshell.
Mhm. Okay, and got it. So now coming industry 4.0. So my uh, doubt is while industry 4.0 is focused on automation and data exchange, industry
Hmm.
5.0 is gearing up to emphasize human-centered innovation. I mean, human-centric innovation. And how do digital twins bridge the gap between these two eras, Industry 4.0 and 5.0? And what new opportunities do they unlock for human creativity in industrial settings?
This is a wonderful and crucial question, highlighting the evaluation of industrial paradigm switch or
Basically, how will
evolution.
we
Right?
position the humans in Industry 5.0 is what I'm trying to.
True. Yeah, that is the key difference between 4.0 and 5.0. 4.0 was more focused on sensors, machines, analytics, and automation, right?
Mhm.
Where obviously the evaluation is 5.0. Having said that, human interference is quite a key in 5.0. Digital twins act as a bridge connecting the data driven automation of Industry 4.0 with the human centric and sustainable focus of Industry 5.0 in several key ways. If we
Okay.
talk about one way, from pure
Mhm.
automation to human machine collaboration is what the
Okay.
manifesto which is yield out of 5.0.
Okay. Got it.
While
So I saw a video a while back,
Mhm,
and where it's more prevalent in China, and I saw that video in basically from a Chinese video
mhm,
channel where they operate the entire quarry by sitting in the remote, and they replicate everything real time in the software and without even going to the place, and they were operating all the machines. They
mhm,
basically created a, as you said, a digital twin of the quarry's machine, and they operated everything remotely, and even they monitored everything. So I think can we say that not only monitoring it, we can even control the systems from remote locations when we implement digital twins.
absolutely not just merely monitoring, as said, it leads towards innovation as well. That's where human part comes in place over 4.0.
Okay.
Let me explain about it. As
Mhm.
said, 4.0 heavily emphasized automation,
Mhm.
sometimes leading to concept about job displacement.
Mhm.
Having said that, if you take China kind of situation, obviously the environment or the situation is better than other countries, right?
Yeah.
Say an example. Obviously, Industry 4.0 was peak at time. There was a demand to elicitate or remove certain uncertainties that is being caused by the automation. That's where human centricity has been placed and defined as Industry 5.0 shifts focus to collaborate between humans and machines.
Okay.
Got it? So
Good.
while Industry 4.0 using data as a primary tool for optimizing efficiency and productivity, wherein Industry 5.0 aims to harness data to empower human creativity and well-being. You can underline the word well-being. We'll talk about it.
Okay.
Digital twins provides rich contextualized data that humans can interpret and use drive innovation, right? For
Mhm.
example, engineers can analyze digital twins and its simulations to identify
Mhm.
new product features or process improvements based on the deeper understanding of real world behavior. In the sense, we
Mhm.
have one of the customer, they are into tearing process or reverse engineering process. We had to uh, transform them from the legacy to digital 4.0. wherein the biggest gap with 4.0 was that obviously it automates and typically do monitoring data and do the analytics based out of it. You could do predictive maintenance. Rather, here the challenge is that the innovation is missing. That is where human centricity comes in place over 5.0, wherein while monitoring there are certain data which is quite critical for the innovation, wherein one of the example, this customer example I was talking about, they were into tearing or reverse engineering process, especially in the automobile industry side. One example I said, while doing reverse engineering, the major part is that to identify what individual components of the car is made up of, what is the size, you can understand, right? Let's say if you take windshield, typically, if I take a BMW's windshield and measure the width of the thickness of the windshield, obviously it is about 8 mm, right?
Okay.
While it is being monitored and quality controlled by the 4.0, wherein there is an interesting fact here to optimize and reduce the cost of ownership, total cost of ownership, by reducing from 8 mm to 6 mm with the same quality and stability. So this is, you understand, right? This is where, while the data is being emitted by 4.0, wherein there were no innovation, wherein human factor involves by analyzing the data with 6 mm itself, the efficiency could be yielded out. If you reduce 2 mm, you can imagine 2 million cars are being sold in the same series or variant. You can imagine if you
Okay.
start
Yeah.
optimizing the cost of one windshield with 2 mm, you can imagine the company would
It's a
save
drastic
billions and
change.
billions of dollars.
Yeah.
Obviously, leading towards total cost of ownership is being reduced, and return on investment is total cost of ownership is reduced. Return on investment is increased.
So based on this, I could understand that it's basically cutting down the manual labor and promotes humans more towards intellectual decision making positions. Uh, did I get that right?
Yeah, it's empower rather replacing humans. It replaces or empowers the human with intellectual or more decision making power by analyzing
Oh,
the data, which is being yielded out of the automation of 4.0.
okay. Similar in to programming world where we moved from machine level to higher level languages. So
Yeah,
here we go from manual labor to decision making processes so that we
correct,
can do more things and produce more. So
correct.
this makes
Along the
sense.
side, the important thing is that sustainability factor. Yes, this all human centricity is being introduced now. Sustainability is the core of
Okay.
5.0,
Okay.
right? What does it mean? It means it plays a crucial role thereby allowing companies to simulate the environment and its impact of their operations, right? By optimizing the resource utilization and design more sustainable products and processes. How? By creating a virtual representation of a business can experiment with crucial economic models by reducing waste and minimize their ecological footprint before implementing changes in the physical world. You got it, right? What I'm saying?
Yeah. Yeah. Got it.
Yeah. Yeah.
So
Other aspect, if it,
data.
sorry, go ahead.
Sure.
Go
Here,
ahead.
so when we talk about digital twins, often as you said, you talk about IoT, AI, and even I've heard about people talk about blockchain. So is there any convergence point that you have encountered where like all these things meet IoT, AI, and even blockchain? Does blockchain fit into any of this situation that you explained?
Absolutely. Blockchain adds other feather to digital twin or digital transformation from 5.0 or from 4 to 5, especially in the security and audit log perspective. So the converge of, in essence, if I talk about the converge of digital twins with the Internet of Things, artificial intelligence, and the blockchain is creating a powerful synergy that is indeed accelerating innovation and significantly enhancing decision making across various industries. Let's if you break it down, there are different aspects and applications out there by combining these all three technologies. Sarath.
Oh, okay.
One of the aspect, if I talk about IoT as this data foundation, right?
Hmm.
The Internet of Things forms the bedrock of digital twin ecosphere. IoT devices and sensors embedded in physical assets, systems, and environment continuously collect the real-time data on various parameters like performance, temperature, pressure, as discussed, and the location-specific geo information. These
Hmm.
are quite vital facts, especially that is being, application of IoT. This
Okay.
constant stream of data provides the digital twin with a live and accurate representation of its physical counterpart. If it
Okay.
combines with the IoT is being combined with AI, obviously
Hmm.
for intelligent insights and actionable predictions, it acts as the brain of the digital twin, especially I'm talking about AI, right? And
Okay.
processing the vast amount of data generated by IoT and transforming it into valuable intelligence. For an example, it helps for advanced analytics, scenario simulation, automated decision making, and personalized experience. It's quite important. Personalized experience is quite vital. Rather, one ring cannot fit for everyone, right? It is.
Yeah.
It is. I mean, a ring will have its own characteristics for different bodies. So, such a
Okay.
manner,
Hmm.
digital twin, along with AI, gives the personalized experience.
Okay. So
And if it,
personalized experienced in the sense, so even in the same industry, factory A can operate in a certain way based on their constraint. Factory B may operate on their own constraint. If we implement the technology, you mean AI can adapt based on the operations in factory A and different operations for factory B?
okay, let me precisely talk about the personalization, right? Let's say
Mhm.
Arunkumar is an employee of a manufacturing unit. I'm really good at manufacturing, especially a process automation side. I'm good,
Hmm.
and in terms of specific skill set, I may not be good at thermal side and ecological side. Wherein Sarath brings his own strength and skill sets. Now, as said,
Okay.
combination of AI which analyzes the humans soft skills and typical workmanship skill. Based
Mhm.
on that, the assignment of a specific task which is being yielded out of digital twin is being personalized based out of individuals mood and characteristics. The tasks are
Okay.
being assigned. The machine itself will be intelligent enough to assign the task to the individuals as in the personalized manner.
Oh, okay. It even could personalize for individuals. So if
Exactly.
based on
Yeah,
their
correct.
expertise, it could allocate
Right.
tasks. That's even
That is a
more.
typical example. There are lots of
Yeah.
other applications out. Yes,
Mhm.
in a nutshell or very high level, if I talk, is based on
Okay.
the individual's skill sets and their characteristics,
That's
certain
very
task
interesting.
which is being assigned by the machines. That is milestone achievement by combining AI, right? Other
Okay.
side, if you talk about blockchain, that is other important aspect that you brought in this. It's a again, data is quite sensitive. Whatever the data which is being emit by digital twin, quite sensitive, right? You
Yeah.
cannot reveal all the data to public cloud, which is accessible to different even within the organization. That's where blockchain technology introduce a layer of trust, security, and transparency to the digital twin ecosphere, right?
Okay.
Particularly crucial in collaborating in data sensitive environments. Say an example, as mentioned, secure data management is quite important. Blockchain's decentralized and immutable ledger ensures the integrity and security of the data associated with the digital twin. It reduces the risk of tampering and cyber threats. That's quite crucial, as said, right?
Okay. People cannot sometimes in industries people just alter the data, you know. to show some different measurements, or even data tampering occurs, we can prevent that, right?
Correct. Yes, and also it enhances the traceability. So audit logs are quite crucial, as you know, right? Especially
Yeah.
in the manufacturing environment, where digital twins can provide auditable and transparent, records of product journey from raw material to the end consumer's consumption, and combating counterfeits, right? And
Okay.
ensuring the authority or
Okay.
authenticity, I can say. It
Okay.
ensures
This
the traceability across.
Okay, got it. So this reminds me of one of the projects that I studied before. So there was a restaurant that serves lobsters, and they
Mhm,
wanted to make sure that the lobster reaches, the uh, proper breed reaches them, and they want to
mhm,
make sure the chain of custody to be maintained in a proper manner. So from capturing the lobsters to delivering it to the restaurant on the plate, everything they were tracking and uploading the data to blockchain. And that way, the chain of custody was tracked using smart contracts. Think in the, as you said, in the industrial specific needs, you could also track the chain of custody using the blockchain use cases.
mhm.
So this just brought, kind of, it's I know it's a tangent, but it brought me to this interesting idea
True,
where
yeah,
they could use
you're right.
blockchain. Yeah.
Traceability and auditable data is quite critical. What happened?
Hmm.
Source of truth is quite critical for the auditing, right?
Yeah.
That's where blockchain mentioned helps. Again, once the data is being pushed, it is immutable. You cannot change. It is decentralized. You don't know where your data is sitting, but it is within our secured environment, where you could do all the phases as you mentioned, capturing. If you take manufacturing side, obviously raw material procurement up to the consumable of that finished good. In
Mhm.
each phase, we know what exactly this particular process or this particular product has gone through. It is immutable. It's unchangeable records out there for the auditing.
Mhm.
That is quite critical for mission critical application development of the manufacturing units.
Okay.
Yeah,
Now going to the next topic, like what are the some major challenges industries face in integrating the digital twins into their existing system, and what strategies can they use to overcome these obstacles?
that is really a good question. First of all, if you talk about the challenges, obviously biggest challenge is that we all have come through legacy model. In the recent past, digital transformation have picked up in terms of increase the total cost of us, decrease the total cost of ownership, and reduce um, sorry, the other way, increase the profitability is quite critical fact for the business, for that matter any business, right?
Yeah.
In that aspect, if you talk about, let's take a biggest challenge that we could talk is the legacy modernization, right? The
Hmm.
evaluation of data, especially and the real-time simulation is poised to dramatically enhance predictive and preventive maintenance and overall performance with industrial setting driven by the increasing sophistication of
Digital twins.
digital twins. Is it making sense? The
Perfect.
industry is
Yeah.
still not yet ready
Got it.
for the race of digital transformation. Why? Take a couple of example, real-time examples that we have worked with. One of our customers, so
Mm.
again, leading car manufacturer, automobile provider.
Okay.
They're number two in the world in the rank, right? So
Mhm.
they have got more than 28 units of manufacturing across the globe.
Okay.
They have have a different disparate or siloed systems across. For example,
Mm.
obviously, when the digital transformation could be of quite successful and get benefit out of it, it's about cohesively together. All systems have to work together. An example, I said, this manufacturer. is trying to implement face by face or wanted to digitally transform them face to face. Eventually, wanted to be a digital 5.0 complaint, organization or manufacturing unit. Having said that, let's take about their ERP. That was quite legacy, right? It is not exposing the data which is sitting within the database. You cannot expose the data outside of the world. As having said earlier, be it ERP and machines, I can say PLM, product lifecycle management system, and the machines sensors emitting data, and these all have to work together to seamlessly achieve the effort. As said,
Okay.
there is an
Mhm.
incident which has happened in a machine, right, or manufacturing unit.
Okay.
What happens? Obviously, that would be sensed by the sensor, which is dedicated to monitor that particular parameter, as having earlier discussed, heat sensor
Mhm.
or thermal sensor.
Okay.
The sensor found it is over bleeding or burning, and the data
Mhm.
has to be sent over to intelligent or artificial intelligence for the further analysis. To do so, obviously, your environment, as said, take an example, ERP should be capable enough to communicate or upstream the data to that particular system. But now the problem is that the ERP is legacy. You cannot do
Okay.
anything. And the environment, obviously, not only again to work AI, obviously you have to have environment where the data to be synthesized, cleaned, and the data format to be unique across. Then only this could be performed. In other words, if I talk about
Mhm.
one year again, ERP is meant for an example, managing their finance and supply chain management. Where in other system is being other siloed system, I can say for HRMS that is
Mhm.
being sitting somewhere. That is also kind of a legacy, or you can consider that is the modern system which exposes enough data to the appropriate places. Now the
Okay.
challenge is that ERP is a legacy.
Mhm.
Modern HR system is good. Why HR system comes in place is that as the this alarm is being emitted or alarm alert is coming,
Mhm.
obviously this has to be assigned to a specific person, right?
Yeah. Yeah.
That data could be obtained from HRMS system.
Mhm.
HRMS system is good, but if you
Mhm.
wanted to identify which machine, what its peripherals and what all it can be done, that could be obtained from your ERP system where you have machine detail, asset details are being there. Now the system is not capable to expose the data. So, in
Yeah.
essence,
Mhm.
for face by face manner also, if you wanted to implement bare
Mhm.
minimum some criteria in terms of modernization aspect, you have to make this compatible across different phases that has to
Got it.
meet. This is the biggest challenge for the legacy, make the legacy organization to be a digital complaint organization.
Got it. So there are situations I've also encountered similar situations where some systems will be legacy system old, like 25, 20 years old. They don't interact with other system like modern systems do. They write data to a file. We fetch the data from the file manually, and we have to like ingest it into, as you said, the modern HRMS system. So
Yeah,
some
correct,
communicate. So before upgrading everything, even if you're doing it face by face, you're saying that there needs to be some mechanism to connect these things and implement that, and then start upgrading the systems face by face. Is that
correct,
correct?
correct.
Got it.
Though again, it's long shot.
Mm,
Obviously, slowly phased manner you have to upgrade. In the
okay.
initial phases, probably the phases could be of seven phases, out of which first two phases you may not see any benefit. But
Mhm.
you have to make sure first two phases are quite stable, and you have to go to the next, and again further move on. Right?
Yeah.
Eventually, you'll get the result. The challenge here is that again, as obviously the business are in pressure to make money and good
Hmm.
margins.
Hmm.
These all capital investment in digital twin or digital transformation itself, capital investment, wherein immediately you won't see the benefit. You will
Got
see
it.
the return on investment in the prolonged period, but
Mhm.
obviously you'll be having huge, impact of this, impact of this introduction of these digital transformations.
So we have to like explain the C-suite of employees and how it's going to benefit the system. We have to show the projection, how it could benefit them and
That
take
is
it
the eventual goal.
to the
That is the eventual
okay.
goal.
Uh-huh.
But as said, an example or classical example we talked about, right? Seven phases. Like first phase could be of your ERP modernization. Okay,
Okay.
that is done. That could take about 6 months to 1 year, right?
Yeah.
Immediately, sudden benefits you will see. These all adverse effects, or I can say
Mhm.
complementary benefits that you will get out of the entire digital transformation. Phase one yield sudden benefits and cost optimization. Second phase could be of modernizing your legacy machines into digital machine or intelligent machine. Obviously, that is the other cost factor or the capital investment. Immediately, that won't result the benefit. Obviously, you have to have data environment where the data could be synthesized, cleansed, and make the decision or informed decision. Together, as said, in this phase, you have 6 to 7 phases is being accomplished. Then only you will get to see the result. Obviously, it could based on the size of the organization or manufacturers, capacity. This varies. Rather, the 7 phase could be achieved in a year of time, or it could be of a 5 years time, 10 years time. Phase by phase, you will be seeing increased productivity and operational efficiency. The eventual goal is to attain the ultimate, operational efficiency. It will take time, is what I'm trying to say.
Okay. Got it.
Yeah,
Understood. So phase by phase, we have to improvise and plan for the future and
correct,
keep going.
correct,
Got it.
correct.
So the next uh, question I have is, so
Mm,
as we stand on the brink of Industry 5.0, what
mhm.
emerging trends or future developments in digital technology you are seeing, and what industry leaders and innovators should be most excited about?
Good question. Obviously, as said, Industry 5.0 focusing more towards human centricity. Why, as discussed, why human centricity quite critical? Obviously, for informed decision making or intelligent or cognitive digital decision making, right? The technologies obviously will get revolved around digital 5.0 by having human centric design or a combination of AI, blockchain. This all
Mhm.
would lead towards different technologies. Probably, I can say human robot, right? Could be of an
Humanoid robot. Okay.
evidence
Mhm.
human robot or
Mhm.
humanoids
Mhm.
could or the human can talk to the robot. Obviously, eventual goal, all we are looking is a robot can talk the other robot and make the agentic robot. The agentic robot will talk, but we are yet to be there. You cannot
Okay.
100% automate everything. Certain decisions still to be made by the our human. That is
Mhm.
where it empowers the humans to make different decisions based on having different technology revolutions. An example,
Mhm.
you'd have heard of cognitive digital twin powered by advanced AI. That is the other topic, or the technology it is revolving or evolving, right?
Mhm.
The machine itself, by having all this data in place,
Mhm.
the machine itself could make the decisions by themselves by having different algorithms of AI and Gen AI is an example. If there is a problem which
Mhm.
has occurred, so far
Okay.
what happens? This is being rule based or rule driven ecosphere that we have at this point. By combining Gen AI is the other wave that we are talking about. We are amidst of the world, right? So
Yeah.
if you combine Gen AI with this decision making, obviously Gen AI has got lots of creativity that
Mhm.
would suggest the problem how this could be solved by the machine itself. Still, human interference is required. The decisions are correct or not. This is where, correct or not, this is being corrected by the human. That is where the human's centricity is quite critical here. If you keep enhancing or teaching the machine, obviously the machines are capable. enough training by themselves, by accepting or obtaining the commands which are being given by the humans. So,
Yeah.
which leads to the self-learning about digital twins. Once the human gives the instruction, that is being learned by the machines, and will same thing could be repeated or could be performed for the further instances or
Or
the
they could
occurrences,
even
right?
enhance their put their own twist to the task, and they could even enhance what we say and
Correct,
do a better job. Or
correct.
as
Continuous learning.
yeah, or as doomsday predictors are saying, they you may say that, but uh, the AI may want to do what it's want to do. So it's an interesting future that we are looking into. So
Absolutely. Along the
yeah.
side, other technology, if you you'd have, we all midst of metaverse as well, right?
Yeah.
Or extended reality.
Yeah.
How it happens or helps is that, say an example, there are places prone towards challenges, right? In manufacturing unit itself.
Mhm.
If you wanted to do or correct certain or do corrective measures in the manufacturing unit,
Yeah.
physically you cannot do all the time. There is an incident or fire accident which has happened in the manufacturing unit.
Mhm.
Obviously, you would call the fire station that would come.
Mhm.
I mean, this could be a different analogy I'm talking about. I'm talking about simulation, right?
Mhm.
If an incident which has happened, what would happen, right? That's why
Mhm.
the drills are being performed.
Mhm.
Rather, those drills could be of merely next to the impossible kind of situation is what I'm talking about. It may not be the
Mhm.
realistic. This where
Mhm.
the if you combine the metaverse in this
Mhm.
incident,
Mhm.
what happens if yeah, you're simulating this environment, if
Yeah.
fire has happened, how
Yeah.
you will predict it, how you will
Yeah.
control the fire, right? If you mix
Yeah.
metaverse,
Mhm.
virtual reality where the person get in, and which are the places that they have to first shut off the machines or control
Mhm.
systems, right?
Yeah.
So
Yeah.
if you mix metaverse, which helps you to the reality while in virtual world. So
Yeah.
metaverse is the other
You
technology which
can
is going to groom along with the digital twin.
you can train humans with lesser cost and even uh, less danger. One such example that came to my mind was uh, even the surgeons who are training for surgery. What they do is they simulate a 3D model of what surgery they are going to perform, and they could perform the surgery. Even you don't even have to waste any materials or even cadavers. You don't need that. You can do that in virtual reality, see everything in real time, and do virtual uh, studies of
Yeah, yeah,
organs and everything you get. And where I'm seeing this may go is, as I said, like in the Chinese uh, dogs and queries where they operate machine remotely. Doctors can operate uh, on patients remotely where there is not much doctors available. For example, a doctor from India can operate a patient sitting in South Africa or some other country where doctors are less, and I think if we use VR, we can perform the operation remotely, and
yeah. You're talking
it
about
would be nice.
rather
Yeah,
VR. You're
yeah,
talking about extended reality. Yeah,
yeah. This is
that is
like the next step I'm
correct.
thinking of.
Yeah, next to metaverse, yeah, you're talking
Yeah,
about extended reality. Obviously,
yeah.
in
The
from
next
remote
step.
place. Yep,
Mhm.
yep. Then this is the essential. Obviously, this is the evolution path from
Yeah,
virtual reality to extended reality, where remote critical operations, or tasks can be done without your physical presence. Yeah, technology supports for all this. Yeah, that's right.
hopefully, if it happens, that would be cool.
Yeah, yeah. It
That will.
started, in Coimbatore itself. I'm not
Mhm.
sure there is a leading hospital
Okay.
did a heart surgery. The
Oh,
surgeon was sitting in US, New York,
mhm.
and the surgery has happened in one of the hospital in Coimbatore, which is completely remote. The
Oh,
operation is
that's
being
amazing.
done by the
Mhm.
surgeon in US. The patient is in operation theater in Coimbatore
Oh,
leading hospital. Right? Yeah, this
mhm.
happened. It was quite successful. It started happening. We are
Oh,
seeing this
it's
in
already happening.
reality.
That's good.
Yeah, yeah. Extended reality is already in place. Yeah.
Okay,
Yes.
Arun, Mr. Arunkumar, thank you for joining the podcast, and we got a lot of information from you. Thank you, viewers, for listening.
Hey, thank you, Sarath.
Thank
Wonderful.
you.
It's a wonderful session. Thank you all for listening to us. Let's stay connected.